Hello, everybody. This is Chandra. Good morning, good day. I want you to listen to me on the lecture 3 where I introduce more operators. The first category of operator or these are called relational operators. They find the relative magnitude between two quantities. The second category is called equality and inequality operators. But these operators, they always give you a Boolean answer, which means it could be true or false. For instance, if I say y equal to 12 greater than 7, the answer is true, and true means 1, false means 0, so y will be equal to 1 because 12 bigger than 7 is true. On the other hand, if I say 10 equal to 7, here I am asking question whether A is exactly equal to B. The answer is no. No means it is false, and that means y will assume a value 0. And over here you see some more example which are very similar to what I said in the previous page. 12 less than 14, it evaluates to true, and on the side you see we wrote the code in Visual C++, and we verify the answers from the machine. And notice true is always printed as 1, false is always printed as 0. And normally we have an expression combined with these relational operator, and one such example is shown here. See, here is an expression on the left, here there is an expression on the right, and we want to ask a question, what would be the value of x? So the way it works here is this proceeds systematically. First you evaluate the left side, and then you evaluate the right side, and finally you apply the relational operator. If you evaluate the left side, the answer is 9, and if you evaluate the right side, the answer is 20. Now the final question here is 9 is less than or equal to 20, which is true, therefore the answer is 1. What you have to understand here is the relative or relational operator, they go at the end after performing all the arithmetic operations first. And we verify this using our Visual C++ system. There are some more operators that helps you to save the space. For example, a equal to a plus b can be replaced by a plus equal to b. A equal to a times b can be replaced by a star equal to b. In general, a equal to a op b can be replaced by a op equal to b, where op may be plus, minus, or star, or division, or modulus. And here we have asked a question, suggest a replacement for the following cases. And if you look at it carefully, This I can write it, this I can replace it, but the third and the fourth, they don't belong to the replacement category because we cannot replace with the shorthand notation. And for another example, right here is if I say C equal to 8 times C, which is exactly same as C equal to C times 8. So I can replace this C star equal to 8. Whereas when I say X equal to 3 minus X, I cannot replace it because this is not of the form A equal to A of B. And there are two more important operators, or unary operator and incrementation operator. And plus plus, it increments the variable by 1. Minus minus, it increments it decrements a variable by 1. And for instance, when I say C++, it is equivalent to adding 1 to C. So these operators, plus plus, minus minus, they operate on one variable, and consequently they are called unary operator. On the other hand, plus or star is a binary operator because they operate on two variables. For example, C equal A star B. Star is operating on two variables A and B. For that reason, it is called binary op. There are two variations of plus plus and minus minus. One is called pre-increment, where we put the operator first, plus plus x. In the post increment, we put operator after the variable. In the meaning in the first case is you increment x by 1 and then assign the value of x to y. Whereas the second case, whatever is x, that we assign to y first and then we increment by x. The point here is x is always incremented by 1. The question is whether y will see the increment or not. In the first case, y does see the increment, whereas in the second case, y does not see the increment. That's a crucial difference between the two. And here there is a simple exercise called programming exercise, and I want you to follow this and try to understand. Now, before we leave, I would like to say something here. Is if I give you a 4-digit number, for example x equal to 4488, and I want to come up with a number y equal to 8844, how to do this? First of all, I want to get 44 and I want to get 88. So to get 44, I take x divided by 100, and to get 88, I want to do x mod 100 to get 88. So this is x1, this is x2, right? x1 equal to this, x2 equal to this. Therefore, y equal to x2 times 100 plus x1. So you're going to use the very same idea in this programming exercise. Thank you for listening to this presentation, and you study it one more time. We'll cover it more in the class, and in the meantime, you please answer the quiz and bring the quiz to the class. Thank you. You have a great day.